Okay, today we're going to talk about climate. Climate, as you can see, is a region's weather over an extended period of time, typically 100 years. They take 100 years of your weather data with your temperature and your moisture, okay, to determine and average all that out to figure out what your climate is going to be. Now, this also includes like number of storms. They have ways of kind of explaining how many storms you get on average in that period of time. Okay? Now, weather. That's just the short-term conditions. It's always changing. Okay? That's your immediate rate at that time. That's what your weather is. We've already talked about all that. Now, the factors affecting climate. Well, you have latitude. Okay, that's one of the biggest ones. Your latitude, because if you're at a high latitude near the poles, 90 degrees north or south, you can expect you're going to have, like I said, north or south, you're going to have cooler temperatures. Okay, North Pole, South Pole, really cold temperatures. Now, if you're at a low latitude, that's near the equator, 0 degrees, you're going to have much warmer temperatures. Okay, people for the summer, people for the winter move from here typically south. Now, how far south? Well, they don't go past the equator typically, because then you start going the other way. People move south, and that's what we generally say, south towards the equator for the winter, because they're going to be warmer in the winter. Now, same thing, they're warmer in the summer too. Okay, that's why a lot of people move back here during the summer, because it's not quite as extreme temperatures. Now, the difference is caused by the amount of sun's energy that strikes the surface, and I'll show you a diagram of that in a second. We call this insolation, incoming solar radiation. That's what insolation is. Each of these different things outlined here. Insolation is the incoming sunlight. Now, this is a diagram. Right here's the Earth. Right here's the sun. And so if you have the sun's rays shining, that's what these are right here, shining on the Earth. And I just showed the Earth straight on, equator not tilted right now. We'll get into that a little bit later. But only if the sun's rays are shining directly on the equator. See how that makes a 90-degree angle right there? So that's a 90-degree angle, highest angle, 90-degree rays. That's very intense. It's going to warm you up more. You're getting more direct insolation. Okay, that's the most direct you can get, is 90 degrees. Now, if you start moving farther north towards the poles, the angle gets lower and lower and lower. I mean, look at how low of an angle that is. The sun at that point is so low in the sky, okay, if you're up at this point, that even the sun, as it shines at us, isn't that intense because it's at such a low angle. However, if you're down on the equator, it's shining straight down on top of you and for a good portion of the day, and that is going to warm you up much more dramatically. Okay. As your angle of insolation decreases, the temperature decreases. As your angle of insolation increases, right here, your temperature would increase. So either way. All right, moving on. Cloud cover. Regions with more cloud cover, higher humidity, meaning higher humidity because you're going to have more clouds, you're going to have lower temperatures. So the more clouds you have, typically the cooler you're going to be. The less clouds you have, clear, you're going to be able to warm up more. All right, large bodies of water. Large bodies of water greatly affect oceans, and lakes are going to affect the temperatures around them. We've talked about it quite a few times, that people around Lake Ontario don't get as cold this time of the year. Okay, our weather forecasts usually say if you're near the lake, you're going to be about 5 degrees warmer because the lake is still warm. Okay, so it cools down and heats up slowly because it has a high specific heat, meaning it takes a lot of energy to change its temperature just 1 degree. Okay, marine regions near the water, near an ocean, near a lake, have cooler summers because the water keeps them cooler, but they also have warmer winters because the water keeps them warmer. It doesn't allow them to get those extremely cold temperatures. So I wanted you to realize the temperature does not change as much, small temperature range. Okay, because if you're next to the water, you just don't get those extremely high and extremely low temperatures that you would if you were farther inland, okay, away from the water. They're going to have warmer summers and cooler winters. That's us, okay? We're far enough away from Lake Ontario that Lake Ontario doesn't affect us. And we have winds that don't come from the ocean. The ocean's on the other side of the U.S., so we're an inland region, okay? We have big temperature range, okay? We can get to almost 100 degrees, okay, not on average, but we can get up to 100 degrees in the summer, and we can get to negative 40 in the winter. So that's 140 degree temperature range. If you live right next to the ocean, you don't have that temperature range at all. It's a lot smaller. Okay, your prevailing winds. Your prevailing winds, there's a diagram on your reference table that shows where the prevailing winds are. Okay, this is page 14, but that's the prevailing wind. I'll show you here really quick. That's the prevailing winds right there on page 14. Okay, and as you can see, between 30 degrees north and 60 degrees north, that's where we are, you have prevailing southwesterlies. So what does that mean? Our winds come from, on average, from the southwest. It's the movement of the air that moves in the same general direction for an entire area. Okay, like I said, page 14. We have prevailing westerlies or southwesterlies. They're called either one. Doesn't matter how you talk about it. That's why I said you understand that our weather comes from the west and moves to the east, or comes from the southwest and moves to the northeast. Okay. Now the U.S. West Coast, so out by California, they have winds from the Pacific Ocean, creating a maritime, because it's coming from over top of the water, a maritime climate. Okay, it's picking up a lot of moisture as it goes across the ocean. The U.S. East Coast, that's us, has winds from across the land, still coming from the west, but only it causes a continental because it's coming from over top of land, continental or dry climate. Okay, so we're a drier climate. However, right next to us, we have Lake Ontario. Lake Ontario helps us have a little bit of a maritime climate, especially in the winter when the lake is warm and the air is cool. Okay, that helps us get a little more precipitation or snowfall because of Lake Ontario. Okay, now ocean currents. Ocean currents are found on page 4 of your reference tables, and that's the movement. Believe it or not, the ocean actually does move. I mean, think about the waves. If you have the waves kind of going a constant direction, okay, that's going to help the water move in that direction. Okay, that's what's taking place to cause ocean currents. Now, like the Gulf Coast, we have what we call the Gulf Stream current, and that warms the east coast of the United States by moving the warm water farther north. Okay, I'll try and pull it up here on the reference table fast to show you, but see the Gulf Stream current, it goes from down near Florida, by the Florida current there, and it moves up to kind of up by Canada, Maine. It is dragging that warmer water from the south to the north. Okay, and eventually it goes over towards England, and another ocean current kind of grabs it there. Okay, we have different names for the different currents on that map. Okay, now move on to the next one. I think most of you know this one. Higher elevations have cooler temperatures. Low elevations are going to have warmer temperatures. Okay, we're not at a high elevation. We're at a relatively low elevation, especially for the area. And but if you go up a mountain, go up on Tug Hill, Okay, there's been times when it's been snowing here, and I was going to go snowmobiling, but it was raining. Okay, here, but by the time I got to Tug Hill, it was snowing. Okay, so that's what takes place. Higher elevations are going to have cooler temperatures because that was what we talked about with layers of the atmosphere. As you go up in the atmosphere, it gets cooler. Okay, so that's how elevation is going to affect your temperatures. Now, it also affects not only your temperatures, but it affects the amount of moisture that you get. Mountains have what we call the orographic effect. One side of the mountain is wet, one side of it is dry. And the windward, the side that the wind is coming from, okay, so if this is the mountain right here, okay, if this is where the wind is coming from, if you have some moist air that comes to the mountain, as it rises up, it cools down. Well, that's the whole process of cloud formation. As the warm air rises, it cools, it condenses, creates clouds. You get enough clouds and you get enough moisture pumping up in here, you're going to get precipitation. Okay, so that's why the windward side of the mountain, the windward is wet or green with vegetation. Okay, that's what takes place. Windward side is wet because you have this warm, moist air rising and cooling and condensing, creating all these clouds and precipitation. It may be snow or it may be rain, all depending on your temperatures. Okay, by the time the air gets on this side, it's gotten rid of all the moisture because cold air can't hold as much moisture, so it gets rid of almost all the moisture. By the time it comes down here and it's coming down the mountain, it warms up, okay, because you're coming down to a lower elevation. We just said lower elevations are warmer. So as it comes down the mountain, it warms up. Well, warm air can hold a lot of moisture, but there's not much moisture to be had there, okay, because it all got out on the windward side. So the leeward side, where the wind is blowing to, is the dry, warm air side. Now, why is it warm? Because you get a lot of sunshine, okay? It's clear skies. Here it's going to be cooler because it's cloudy all the time. You get desert-like conditions on the leeward side of the mountain, okay? So those are just some ways that climate is affected by these different conditions that we just talked about here.